Hey there, students. It's Mr. Pouts. So we have section 4.5. I'm going to try to keep it brief, but our goal here is to write equations that represent, be able to write equations that represent functions in the real world. So we're going to come up with the equations. You're going to create the equation to represent a function in the real world. And sometimes we think this is a tough thing, but we're going to review something that we talked about earlier in the year, this CUBES acronym. So when you're given a word problem, we just want to be able to write the equation. So start by circling any key numbers. So key numbers that might be part of the problem. Underline the question that we're trying to do. Boxing any math action words. Writing in the equation, and then ultimately solving and checking if we're asked to. So especially these first three, and then the fourth one are the really important ones for right now. When it says box any key math action words, um, these are some that we came up with earlier in the year for the different operations. So for addition, something we came up with, and there might be more. We have add, plus, increase, um, added, and how about more? That's one that we missed as well. More. Those are all keywords that would signify addition. Some that might do subtraction here. We have less than, less, minus, subtract, decrease. Um, yep, those are all good ones for subtraction. There might be even more. Multiplication, times is a per, of, multiply. I think each would be another good one. And then division, you could say divided by, divide, split. Um, there's not a ton more for division, but if you can think of one, sure enough, write it down. And then equals. There's always got to be an equals if we're writing an equation. So a key one is, or total. But if we have is equal to or equals, those are also key ones. There's some other ones that could be as well. So we're going to start off by talking about writing a function rule. There's not necessarily a strict set of guidelines other than cubes. This is how we do it. Right here, cubes. So some of them are easier than others, but this one says you can estimate the temperature by counting the number of chirps of the snowy tree cricket. Interesting. So if you have a snowy tree cricket, you can estimate the temperature outside by how many chirps they do. Um, so the outdoor temperature is about 40 degrees Fahrenheit more than 1/4. All right, so we're gonna say, here we go. Keyword, circling key numbers. 40 and 1/4, even though it's a word, that would be representing the number 1/4. Boxing the question, or underlining the question, what is the function rule? All right, and then boxing into key math action words. I already found one. Is, it's going to be equals. More than, I think that's plus 1/4 the number of chirps it makes in 1 minute. I'm guessing this is going to be 1/4 of the number of chirps, so I'm going to say box that. And so let's take this. According to the way that it was stated here, it says the temperature is, so again, there's our box, 40 degrees more than, that'd be plus 1/4 of the number of chirps in 1 minute. So we're going to make T be the temperature because that's what we don't know. And the number of chirps in 1 minute we don't know either. So we're going to replace the temperature with T, is with equals, 40 degrees with just 40, more than with plus, 1/4 is staying there, of would be times, and the number of chirps is n. So there's our function rule, T equals 40 plus 1/4 n. I'll say it, I've said it before, I'll say it again. Writing equations, a lot of times, it's just given in order of how it is. Look for the keywords and numbers and try to write that in order. So why don't you try this one on your own? And I have these underlined for you. We're going to do another one, but these are actually underlined for you in box. It says a landfill has 50,000 tons of waste in it. Each month it accumulates at an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? All right. So, why don't you try that one on your own first? All right, this is what I got. I have total is going to be write a function rule that represents the total amount of waste after m um, months. So total we're going to say t. So t equals, okay, it says it has 50,000 tons in it. So we're going to have the 50,000 tons. Each month it accumulates 420. Now 420 each month, we said, um, well, let's actually write this out first. Let's move this down a little bit. We know that the total equals 50,000 tons and 420 more each month. So we're having T would be our total equals 50,000. Oops, sorry about that. And so we're going to say plus 420 each month. So times M. So that would mean you start off with 50,000 and you add 420 each month. So you can plug in for M and end up getting how much waste you'd have that month. All right, so that is writing a basic function. Now let's look at a different one, a different type of situation. Maybe evaluate it as well, but we're going to really focus on writing it. It says a concert seating plan is shown below. Reserve seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold because the reserve seating is sold out. So it depends on the general seating. Here's our question. What is the maximum possible total revenue? Write a function for it to represent it. All right. So this one's tough because it doesn't have all the information in the problem. But we know quite a bit of stuff. We know that the revenue comes from the sold out seats, which we have over here. That's already reserved, sold out. So we can actually figure out how much that would be costing. And then plus the general seating. And the general seating would be $10 per ticket. And we have to multiply that by however many tickets are sold, right? So if we take that information, whoa, 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 whoa. We take that information, and this obviously going to be an equal sign. And we're adding the plus, so that's going to be plus. General seating, we don't know how many people are tickets sold. So we're going to say this is N. So the price per ticket is $10 times N plus whatever the reserve seating is. So we can actually figure that out. If it's $20 per ticket, there's 10 rows and there's 12 seats per row. So that would be 120 seats total. So 25, well, times 10 rows times 20 or times 12 will get you that. That's going to be our total revenue. We'll say is R. I'm going to take my handy dandy calculator here. Hold on one second. And do 25 times 10 times 12. So that's where we get 3,000 right here. Already sold. We already made $3,000 from the reserve seating, plus $10 for every ticket we sell. That would make up our revenue. All right. It says what is the maximum possible revenue? So if we have 30 rows and 16 seats each, 30 times 16. I'll check it on here real quick. Whoops. 30 times 16. So that'd be 480 seats. We have 480 seats that we can plug in there. So if we were to plug that in for our N, and I'll do that in a different color, we'd have R equals 10 times 480 plus $3,000. So that would be 10 times 480 is 4,800 plus 3,000. So the revenue could be $7,800. That would be our total possible revenue if it was a full house. All right, here's one problem for you to try. It says a kennel charges $15 per day to board dogs. So $15 per day. Per would probably be a times. To board dogs. Upon arrival, each dog must have a flea bath that costs $12. So we're going to have to pay $12 no matter what. Write a function rule for the total cost of n days of boarding plus a bath. So there's what we're trying to find, the total cost. And the second question is, how much does a 10-day stay cost? So let's put this together. $15 per day. So our total cost, we're going to say total cost is equal to $15 per day. So 15, and it says n days, plus we have to pay $12 because a bath is required. So there's our function rule. Nice. And then it says, how much does a 10-day stay cost? Well, if we're doing 10 days, that 10 days would have to go in for the n, because n is representing days. So t would equal 15 times 10 plus 12. T would equal 1500, that's 150 plus 12. So T would equal $162 for 10 days. All right. I hope that went well. All right, last one, a possible nonlinear function. So here's the situation here. We have, write a function rule for the area of a rectangle whose length is 5 more than its width. What is the area of the rectangle when its width is 9 feet? So we're just going to focus on writing the function rule first. So here's our step-by-step process. First, represent the general relationship. The area, we can tell area is length times width. Okay, so we have our picture. We're given then that we want to show that the width is actually, or the length is actually 5 feet more than the length, or sorry, than the width. So actually we're going to change length to w plus 5 because we know it's 5 more than the width. So w plus 5 can represent the length. Now we are going to use the diagram to show the function rule. The function rule, so for area, if we find area, it's length times width. So length times width, in this case, area would be equal to w plus 5 times w. And that's shown right here, w plus 5 times w. Or, if you were to distribute, we'd have w times w, which is w squared, and w times 5, which is 5w. That's where that comes from. And then the question being asked is, what would it be if the um, width was 9? So you plug in 9 for the width, plug it in for the w there, plug it in for the w there, and it's shown right here. You plug it in, it's 9 squared um, plus 5 times 9. That'd be 81 plus 45, and you get 126. So when the width is 9, the area is 126 feet squared. So I'm going to leave you with this question. It's the last one. Try to figure this one out on your own. It says, write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. What is the area of the triangle when the length of the base is 16? So we're really looking for, in number 3, write a function rule for the area when it's more, when the height is this and this. All right, just remember height or area of a triangle is 1/2 times the base times the height. All right, good luck with it. All right, real quick here, what I did was I changed from showed them my picture with the area would be the base and the height, but we're told that the height is 4 inches more than twice the height, or twice the length of the base. So that's, I represented 2 times the base plus 4. So when you plug that into the formula, it's actually 1/2 times base times 2 times the base plus 4. So I just distributed here. Did b times 2b would be 2b squared, and b times 4 would be 4b. And then I distributed the 1/2. 1/2 times that would be just b squared, and then 1/2 times 4b would be 2b. And this is where I got my formula. Now if I wanted to check it with the base of 16, I can plug that 16 in for the b right there and right there and get out the area. So that is all for today. Please make sure you look at your goal and think about what you learned, what you don't know, what you maybe have questions on, about the goal of writing equations that represent functions in the real world. We'll see you next time.